Hello, my name is Dr. Coca, and in this video, we're going to be finishing up procedure one for part B of the Grignard reaction. So, part B deals with taking a Grignard reagent and doing a Grignard reaction. So, in the previous video, we added the Grignard reagent that was formed from bromobenzene and magnesium. We added that to uh, a benzophenone solution to do a Grignard reaction, and the product from that reaction we placed on ice. So here is our solution. It is fairly close to being a solid, and we're going to add now 6 molar ACl to that. So we need to add 5 milliliters of ACl, which I already have in this graduated cylinder. We're going to add that to our beaker, and that should destroy any unreacted magnesium or even Grignard reagent that hasn't reacted um, at this point. Once we mix it together, we can transfer that into our separatory funnel to do an extraction and purify the product. If we transfer this over, and perhaps use a little bit of ether to make sure our product is transferred over. Just a little bit more. So now in the separatory funnel, we should have our product as well as an aqueous layer from the 6 molar ACl. So you can see that here. You are supposed to know at this point which layer is which. We really have a mixture of ether containing our product plus ACl, which is primarily water. Water is more dense than non-halogenated organics, so it should be the lower layer. But again, if you don't know which is which, you can add either a little bit more ether, you could add a little bit more water and see which layer grows. Once we let that sit for a minute or so, we're going to take out the aqueous layer, so it should be the bottom layer. If we open the stopcock, and let the aqueous layer drain. At this point, we're going to add approximately 3 milliliters of brine. So I'm going to eyeball this. It doesn't have to be very accurate. So brine, having a lot of sodium chloride in it, should pull out most of the water that's in the ether layer at this point and bring it into the aqueous layer. We want to make sure we mix these two together. So I put the stopper on, shake it a couple of times, and vent it away from you. And set it back down. Let it sit for about a minute or so, and then we want to drain out the aqueous layer once again. So just like before, brine is a solution of sodium chloride in water, so it's primarily water. Water would be more dense than ether, so it should be the lower layer. So we're going to grab a second Erlenmeyer to catch the aqueous layer. So we're going to open the stopcock and drain the aqueous layer. Okay, so once we drain the aqueous layer, we have left in the separatory funnel ether plus our product. So this is our organic layer. We're going to transfer that into a third Erlenmeyer flask. And I'm just going to do a quick rinse of the separatory funnel. Make sure we get the product out. So drain it once again. Now some solid is for some reason staying behind, but that's okay. We don't need to get all of it for this demonstration. So in this flask here, we have our organic layer. It's sort of a cloudy yellow color. And the cloudiness is probably from the product not being completely soluble in ether. We're going to dry this at this point. So we would add sodium sulfate. And we really only need a very small amount. Again, sodium sulfate is just to get rid of the trace amounts of water left in this organic solution. So we stir that up and we let it sit for about maybe 5 minutes. At that point, you would add a small amount of hexane. You would transfer that solution into a secondary container, an Erlenmeyer flask, and you place it in a hot water bath to evaporate the ether. It should leave behind most of the product plus just a few milliliters of hexane, which has a slightly higher boiling point. At that point, you want to do a filtration to get the solid product out. You'll rinse the crystals with hexane, and so the crystals at that point would be just your product. So through the filtration, you separate the product from the solvent, which at that point would be just a small amount of hexane. By rinsing the crystals with a little bit of hexane, we'll get rid of any impurities, if any are left. And if you let the product dry for a few days, it should produce a very pure product. So at that point, you're pretty much done with the experiment. You would have to weigh out the product to determine percent yield. And then you also want to do an IR to confirm the fact that you produce the product from the Grignard reaction and not something else. So that concludes this experiment.